Alright guys, so now we are going to work with this section 5.1, lecture 5.1, fundamental identities. The big idea is the identities can be used to simplify complicated trig equation, and you should be able to use the basic identities in this section to manipulate trigonometric expressions. So you have a list of all the fundamental identities you will have to be able to manipulate. Let's jump right away to the practice number 1. All right, so in this problem, what do we have? You have the value of the cosine of the angle theta equal 5 over 8 for theta being in a quadrant number 4, and find the value of all the other trigonometric function. So first, one of the identities that I like to use very often is the identities saying that the square of the sinus of the angle plus the square of the cosinus of the angle equal to 1. I know the value of the cosinus, so I can fairly set that the sinus square of theta plus 5 over 8 square equal 1. Therefore, we got sinus square of theta equal 1 minus 25 over 64, as 5 over 8 square equal 25 over 64. Same denominator, multiply by 64 top and bottom the 1. And I end up to have sinus square of the angle equal 64 minus 25 divided by 64, and end up to have 39 over 64. 39 over 64. Now, sinus theta is going to be equal to plus or minus square root of 39 over 64, which is plus or minus square root of 39 divided by 8. Because theta, let me do the S much better. Because theta is in a quadrant 4, is in quadrant 4. What does that mean? It means that the sinus of the angle theta will be negative. Okay? So that means that the value of the sinus we found is going to be negative square root of 39 divided by 8. Knowing the value of the sinus now, and knowing the value of the cosinus, I think it's pretty easy now. Knowing the value of sinus theta and the value of the cosinus theta, I can easily calculate the expression of tangent theta, which is sinus theta over cosinus theta, which gives me a negative square root of 39, negative square root of 39 divided by 8 over 5 divided by 8. I convert a main fraction into a multiplication. Therefore, my numerator doesn't change. I convert the main fraction by multiplication, and therefore I need to flip my second fraction. The 8 divide out, and so the tangent of my angle is going to be negative square root of 39 divided by 5. Now, I'm going to let you work on the sec of theta, which is 1 over cosinus theta. I'm going to let you work on the cosec of the angle theta, which is 1 over the sinus of your angle. And I'm going to let you work on the cotangent of the angle, which is 1 over the tangent. All right. In the example number 2, we have to express tangent theta in terms of only cosine. So first of all, what I want to do is replace, substitute sine. So I know that sine square of the angle plus cosine square of the angle theta equal 1. So sine square of the angle equal 1 minus cosine square of the angle. And therefore the sinus of the angle equal plus or minus 1 minus cosinus square of the angle theta. I took the square root. So my tangent theta, so tangent of the angle is going to be plus or minus the square root of 1 minus cos square theta divided by cosinus theta. How to decide which expression I'm going to take? Is it going to be plus or is it going to be minus? That is knowing in which quadrant you will be, and that will help you to define which sign you are supposed to find. All right, now let's jump on the next problem, and we need to rewrite sec theta and cosec theta in terms of sine and cosine function only. Well, I know that sec theta equal 1 over cosinus of the angle, and I know that cosec of the angle theta equal 1 over of the sinus of the angle theta. Therefore, sec theta plus cosec of the angle theta equal 1 over cosinus theta plus 1 over sinus theta. I don't have the same denominator. So if I don't have the same denominator, I need to define the LCD. What is my LCD? To calculate the LCD, I need to write each denominator. So I'm going to write the denominator cosinus theta and the denominator sinus theta. And I'm going to completely factorize into prime. Well, in that case, cosinus theta is going to stay cosinus theta and sinus theta is going to stay sinus theta. The LCD is the multiplication of each factor with the highest power. Obviously, in that case, the LCD is going to be factor sinus theta multiplied by factor cosinus theta. That helped me to define that I need to multiply the first fraction top and bottom by sinus theta, and I need to multiply the second fraction by cosinus theta to have the denominator looking like the LCD. So now I am with sec theta plus cosec of the angle theta equal sinus theta plus cosinus theta over cos theta sinus theta. And that is the answer in writing sec theta plus cosec theta in terms of sine and cosine functions only. All right, so we write the tangent theta plus cotangent theta in terms of sine and cosine. Well, it's going to be the same idea. First of all, you are going to say tangent theta equal sine over cosine, and cotangent, it is cosine over sine. So therefore, when you are going to try to express tangent theta plus cotangent theta, it's going to be sine over cosine plus cosine over sine. You don't have the same denominator. You are supposed to find the LCD. The LCD is going to be exactly the same than previously. The LCD is going to be sinus theta cosinus theta, which means I need to multiply by sinus theta, this one, top and bottom, and I need to multiply by cosinus theta, this fraction, top and bottom. Therefore, I end up to have sinus square theta plus cos square theta over sinus theta cosinus theta. But I know that sinus squared theta plus cos squared theta equal 1. So the answer is going to be 1 over sinus theta cosinus theta. Now use a calculator to conjecture which of the following is true, which equation is an identity. Okay, so that's super easy. We are going to graph both sides of the equation. So first, graph on the same graph sinus 2x and 2 sinus x. You are going to do the same thing with the other one, sinus 2x and 2 sin x cosinus x. If it is an identity, if it is an identity, the graphs will be the same. So guys, I graph for you sinus 2x equal to sinus x. I can see clearly that I don't have the same graph, but when I graph sinus 2x equal to sinus x cosinus x, I get exactly the same graph. So this one, yes, it's an identity. On the other side, this one, it's not an identity. All right, thank you guys. I hope you have everything you need and see you in class.